All right, good morning, gentlemen. There are two reasons why we are doing this part of the class on the video today. One reason is I want you to see what these videos look like so that when you go home, you're more likely to take advantage of them if you think that they could be helpful or if you feel like you struggled in class. The other reason is sometimes it's good to break things up and do a little bit different. So what I want you to do is to track the page in your first packet that says frame at the top and how can we calculate probability when not all outcomes are equally likely. Yesterday we talked about probability models where all of the outcomes were equally likely. So for example, if I had a spinner that was divided into 4 equal parts, I would have a uniform probability model where my outcomes were equally likely. But we're going to take a look today at what happens if that's not the case. So Ms. Impink, Ms. Shah, and Ms. Faison are playing a board game with a spinner. They can only move their game piece forward if the spinner lands on their color. Okay, you can only move. What is the probability of the spinner landing on each color? We're going to complete this chart below. So I'm looking at my chart over here, and I have 3 colors. I have yellow, I have blue, and I have red, okay? But I'm looking at this spinner, and it looks way different than, for example, the spinner I drew up here. And the difference with this spinner is I have this really large section of red, and I have 2 much smaller sections of yellow. So looking at this, it looks like it's about divided in half. And so the red looks like there's about a 2/4 or 1/2, 1 out of 2 chance that you would spin it. For yellow, that looks like about 1/4. And for blue, that also looks like about 1/4, okay? And so these are percentages that you should know. 0.25 equals 25%. 0.25 equals 25%. And then 1/2 obviously is equal to 50%. Make sure you have that on your paper. Okay, moving on. So we want to predict with this non-uniform probability chart here, how many times each color would be spun in 30 spins, okay? So for blue and yellow, it's going to be the same. So for blue and yellow, I know that there's sort of a 1 in 4 likelihood that it's going to happen. I'm going to set that to X over 30, okay? Boom, boom, boom. So to get from 4 to 30, I had to multiply by 7.5. So to get from 1 to X, my answer is going to be 7.5, okay? So I have 7.5 times for blue and yellow. Now you might be thinking, Messiah, you can't roll or you can't spin this 0.5 times. That's correct, but you can have a fraction in a probability chart. So now taking a look at red, we know that's 1/2, and that's pretty much mental math, right? I know that it's going to happen 15 times. All right, given the format of this spinner situation up here. So the one thing I want you to do now is I want you to write at the bottom of this paper, because we learned about this as a game, is this game fair? Why or why not? Now, guys, I know that you're all going to know the answer to this in your head and get it right. I want you to take this opportunity to practice writing in a complete sentence. I'm going to give you 45 seconds. before I move on. Okay. So we are going to skip the additional at-bat, and I want to look at the independent practice medium here. So if you guys go down and find your independent practice medium, Ms. Garcia spins the spinner below one time. Create a probability model. Okay, so let's see, what are the different colors? I have blue, I have green, I have red, and I have yellow. Let me just make sure I didn't miss any. Okay, and let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so my blue is going to be 1, 2, 3 out of 12. My green, also 3 out of 12. For red, 1, 2, 3, 5 out of 12. And for yellow, there's only one yellow here, 1 out of 12. Okay, so this is a non-uniform probability model. And let's take a look here. Mr. Chan buys a gigantic bag of 200 M&Ms. He randomly chooses one M&M out of the bag 40 times and records this data. So let's take a look. Here we go. We have blue. He got 8 blues. He got 10 oranges. He got 7 greens. He got 5 yellows and 10 reds. Based on this data, what is the probability that another M&M chosen from the bag would be green? Okay, so let's see. Express your answer as a decimal or percent. So I'm basing this on his data, which means this is not theoretical. This is me basing it on an experimental probability. And so if I add these all together, I have 10, 20, 5, 32, 40. So there are 40 total. So there is a 7 in 40 chance that we're going to pick out another green one. As a decimal, that's 0.175. And as a percent, it is 17.5%. Take some time to get that on your paper. Now you're going to have time to do your exit ticket. So if we move down here to the exit ticket, your probability model, I want it to look like this. With each of your different kind of marbles and then the number. Okay, that'll just be the easiest way for us to grade that. So you're going to have 5 minutes to do this. This is not a difficult exit ticket, and then we'll be moving on to the next section.